Today we will be discussing Python and introducing you to this coding language, which will kind of build off of this understanding we created of Scratch last lesson. But before we start, I would like to do an icebreaker where you can share out loud or type it in the chat. And I would like to discuss how whatever your understanding of code is affects your everyday life when it comes to using technology. So whether you're using it on your phone or on your computer, on any device, and for any use, whether you're playing a game or searching something up on Google or doing schoolwork, how does just this general umbrella term of code affect that use of technology? So take a few minutes to think about that, and then we can share out. Yeah, and if anyone has if people would like to just share in the chat or say out loud, any ideas are welcome.
I think codes literally affect every day of your life, of our lives, really, because the computers that we use in the first place, so the software is all built on codes, like you've literally said from the start of the class.
Are there any ideas? Okay, well, I'll go first. When I'm doing my homework and I need to type something up. Oh, let's see. I have in the chat, Lion is saying codes are used in everyday life, from software to tools like microwaves. Yes, that is a great point. So even things like warming up food in the microwave or searching something up in Google requires code. And this is why I kind of wanted to use this umbrella term of code, because code is so much. Code can be the block code from Scratch, and code can be lines and lines of code in Python or C, right? Code can be an incredible amount of things. So it's important to create this understanding that, yes, even something like a microwave or keeping the time on a microwave uses this idea of code. So yes, that's a great point. Are there any other ideas? Just feel free to share in the chat. We'll spend a few more minutes on this and then we can move on. All right, then we will move on. So I want to start by giving a slight recap from last lesson, just because it's been some time. So last week we discussed the black box theory, which we'll go over soon, and the way Scratch, this block coding program, where you can kind of drag blocks of code that will do certain actions, can help with getting an understanding of how coding and algorithms work. So this here is written out code, right? And the idea is that we use a program like Scratch where you can drag these codes, where these codes can be dragged in blocks. So everything you need done will be in this block, and it will affect the sprite or the cat on the right of the screen. So the idea is today we'll be learning Python where none of this is done for us. We have to write every single action we want done out. And therefore, it is good to first begin by learning kind of the understanding and the language that needs to be used before actually writing it out. So what is the black box theory? For a quick recap. The black box theory is this idea that we have an input, and from an input we get an output. And whatever is in the black box is what allows us to convert what we give a system to what we get out of the system. So in this case, we will be thinking of this black box as an algorithm. So sometimes it can be Scratch, sometimes it can be like Python or C, it can be anything, right? And it's just whatever we want a system to do, and then we give it an input, we will get this output, which means the full theory looks like this. We have the input, something is being done to it, and we're getting a new output. Yeah, someone's asking if I can explain again the black box theory. Yes. So the black box theory is this idea that we have an input. So all systems must have some kind of human, not human input, but some kind of input. Because if there's nothing you give a system, there's nothing to do with it, right? So we have an input. Now, the goal of every system is to take what is an input and get an output out of it. So to take, let's say you're searching something on Google. The goal is that you can search how do you spell a certain word. And from that, you got an output with all these results of how you spell that word. Correct? So it's this idea of a system is given information and then they're given instructions, which in this case is our algorithm of what to do with that information. And this creates the full black box theory where they're given this information, they're given instructions of what to do with the information, and then they spit out this reprocessed information, which can then hopefully be used for more efficiently and can be more helpful to whatever it needs doing. Does that make more sense? Yes, okay, great. Now, today we hope to apply the same understanding with a coding language called Python. Now, let's discuss what Python even is. So Python is a computer programming language that is known for being easy to read and write. So it's kind of the system that can do a lot, but kind of can do a lot, but kind of is used as a base, as kind of a more simpler version of coding languages. So it's like learning a new language, except instead of communicating with other people, you're communicating with a computer. So a computer needs to be very efficient, right? So in order to give this understanding, or in order to have a computer do a certain action, you need to be able to speak its language. Because if you want it to speak your language, it will be much less efficient because it needs to be able to understand all these different ways that different humans speak. But if we all learn to speak one way, which for example is Python, a computer only needs to be able to understand Python, and that will allow it to be much more efficient. Now, it's very straightforward, and it can focus on grasping very individual things, which is the idea of Python. And it's used for many things, from making websites, analyzing data. We spoke about like data science, so Python can be used for that, and I showed you some examples in that lesson. Automating tasks and building software and games. So Python is, while it's a rather simple coding languages, it has such vast use cases. Now, before we dig too deeply in, there's an important term called syntax. Oh, does anyone have any questions? Or... Okay. There's an important term called syntax. So in terms of Python, syntax refers to the set of rules that define how a Python program is constructed. So it encompasses the structure of the code, the correct use of all the punctuation and words, and in simple terms, when compared to speaking English, to speaking, a non-computer language, it can be compared to grammar. So it just is, was this comma used here? Was a period here? But of course, in Python, as in here, it would be more colons and parentheses and quotation marks. So yeah, so if you were asked what the syntax is of this this code below, what would you guys think it is? Just share in the chat, or you can just speak out. What would you think it is?
Okay, I think it says that like if a condition, like to give it the condition, like if the condition is true, you should do that. Then if it is not, you should do another condition.
Anybody?
Then if that is not true, you should do the last else condition.
Okay. Well, this set of code would be a conditional statement. So yeah, it's just simply the grammar of the code. So here is the conditional statement. Now, last week we went over some important terms that are, as in this umbrella idea, are important to all kinds of programming. Okay, so I figured it'd be good to quickly go over them again. So firstly, we have functions. Functions is a block of organized, reusable code that does one single thing. So in coding, a big challenge, but also a big benefit is that you can really hone in on one specific action, one specific want, right? So instead of wanting to do all these things, here this function, there's one function of this code, and that is to find the area of a rectangle. Now, the computer doesn't automatically know what the area of a rectangle is. So we begin by telling it. We say, look, computer, my definition of area is length times width, right? As you can see here. So this is how I define area. Of course, maybe someone defines it differently, or they have something else, right? So for computer, when they see the term area, they understand length times width. Now, a computer doesn't know what length or width is either, but for people to look at the code and understand, we use a language that is familiar to us. Now, the function of this code is to find the area of the rectangle, right? So we will say it is length times width, and then we will give it both the length and the width, and we will tell them to multiply it. Now, a computer can do basic operations like multiplying in those numbers. So if we give it the 10.5 and the 4.25, and we say, look, the area is the result of multiplying these two together, the computer will automatically know it needs to do 10.5 times 4.25, and it will get 44.62, right? Which now is written here, but that is the one function of this code. It has one task. Does that make sense to everybody? Yeah. If you have any questions, you can feel free to ask in the chat. No. Next, we have conditional statements. Conditional statements simply look for a few keywords. They are simply this idea of if and then, which means if something happens, then do this. If something doesn't happen, which can also be, you can also say else, then do this. So a way to understand this would be with student scores based, like your letter grade based on what number you get, right? So if you are greater than or equal to a 90, it says to return an A. And then this cycle keeps going down until if you're below a 60, you no longer need you no longer need else if, you only need else, because once you're below a 60, you will always have an F. So conditional statement is simply this idea of if something is the case, something else is the case. And if it's not, you move on, right? So it's this if, then, else, if, right? So the key words are if, then, and else. Then there are Boolean expressions. A Boolean expression is simply this idea of true or false, right? You either are or you aren't, but there's no in between. So in this case, it's asking, it's a code that figures out if you're eligible to vote, okay? And it says, once again, the computer doesn't know how old you have to be to vote. So we define for it that to be eligible to vote, you have to be 18. And then we say that the age of a person in question is 20. Right? So since 20 is older than 18, there was only a true and there was a false, right? True is yes, you can vote. False is not. And you were either above or below or equal, of course, but that means you're true. So Boolean expression is just the idea that it's a yes or a no. And that's also important to understand. Now, moving on, we have loops, which are pretty simple. It's just instead of manually typing out to find all the multiples of 3, instead of manually typing out 3 times 1, 3 times 2, 3 times 3, we can simply say, say I is all the numbers between 1 and 6 here. And then we can say to do 3 times I and print the multiple of each. So instead of this, which is 1, 2, 3, 4, 5 lines of code, we only need 2 because of the use of a loop. And then last but not least, there are variables. Variables are used to store information and kind of use them to be manipulated in the program. So the same idea of being able to vote, right? It stores the information that the user is 25 and will move on with that. And that's an important idea. Just like with the area of a rectangle, it stores, because you have to define all these things for a computer, right? A computer doesn't know how to solve for area. A computer doesn't know how old you have to be to vote. You have to define all these things. And then that is now seen as a variable for computer. It's the X, it's the I, right? And then like the I in the last code where we're using loops. And then a computer knows, oh, look, I have this variable and here is what I can do with it. Does that make sense to everybody? So those are just 4 important terms which will be deemed rather important throughout this presentation. Are there any questions? No. Okay, we're good. Now, we're going to look at some history. So Python originated right after the ABC programming language. So the ABC programming languages was developed in the early 1980s in the Netherlands, and it is a high-level interactive and simple programming languages, which was designed very much for teaching. So people didn't really make huge programs with the ABC programming languages because its goal was more to have this simplistic idea, right? It has a very straightforward syntax. It's very readable, and it ended up having huge influence on the creation of Python. But this was kind of seen as the scaffolding before that. So here's an example of what it looked like. It was built in the early stages of coding. So while it wasn't necessarily a good system, it was very simple. So here is a system which can like return words in a document, right? So you just tell it exactly what you want it to do. You put your brackets around a collection, and then you do all these different actions with the words, and then you return it. And you just type to it exactly what you want it to do. Now, this is important because it kind of brings up this idea of Python's creation. So Python was in its very, very early stages. It began in December of 1989 by Guido van Rossum in the Netherlands, and it was a successor to the ABC programming language. So as you saw, the ABC programming language was very simple and had a very limited amount of actions that it could do. And people saw code as this opportunity to do more and more complicated things. So they figured, let's kind of branch out from the ABC programming language and create a language called Python, right? So then in 1991, just a few years later, Python 0.9 was released in February. And this initial version already included things like exceptions, which is this like if then else functions, and basically these core ideas which coding today has. So it's interesting because we see something that's created in 1991, almost 30 years ago, or yeah, more than 30 years ago, which already included things that are still used today. And then in 94, Python 1.0 was released. And with this release, Python kind of established itself to be, it became more and more widely used. People saw how useful it was, how good it was, how it was kind of on this, it walked this wire, it walked on this fence between being simple enough that everyone can use it, but also being complicated enough that it has a lot of actions. So yes, while the ABC language was very simple, it couldn't do much. And this was simple, a little more complicated, but still simple, but could do a lot. And then finally in 2000, Python 2.0 was released, and it introduced some new things, and it it uh, it allowed Unicode, which basically was a way to code and make it more capable internationally, that more people could use it. And looking at the present, not the past, from 2022 to today, we see version of Python 3.9, so way later, and we're getting now that this. So coding has kind of been, the idea of coding is kind of a very rigid concept, but there's many other things that can change, such as new syntax features, library updates, and optimization improvements. Library updates are basically that when you say to do a certain action, Python, the program needs to know what that action is. So for that, you can import a library where it gives directions for what each thing should do. So even though, no, that library won't necessarily say what the area of the rectangle is, it will say how to say area, where to say it, when to say it, in what font, what size, and what color. And this is why also this understanding of Scratch was very important, but also much simpler, right? Because that one block had all the information in it, and here it needs to be written. So now we saw this timeline, and we see how a lot of the things from 89 are things we still use today. So it brings up this question of how can a coding language improve? And a coding language can improve in many ways, and they seem rather minor, but they make coding a process which can be more and more and more efficient. So, for example, enhancing syntax, making like features in coding that are more and more applicable and more helpful and more advanced, right? Like F strings for easy string formatting, so that when you want to type something, you just have to write it in, right? And then additionally, speed, right? Coding can be a really long process, especially when it's big websites, big programs, right? And over time, Python became a program that could be more and more, that could be faster and faster, in essence, right? With that, using loops, using these ideas that can make writing code, in essence, more and more efficient. And then there's long-term support. The transition to Python 3 from Python 2, sorry, was a significant milestone because it kind of ensures that while the world gets newer and newer, and devices and hardware gets newer and newer, that this actual code can kind of keep up and stay modern and maintainable. Because the moment Python falls behind, it becomes useless, right? Because it needs to keep up with the newness of, or the modernness of, the actual devices we have, and also the things that we as people demand from it, right? So I'll take a few questions. Are there any questions? You can ask in the chat. Anyone? Just feel free to. Yes, Adrian, feel free to share it. Adrian, do you have a question? Feel free to also ask in the chat if you're having issues, but I would love to answer your question, Adrian, about this material or about anything.
Hello.
Okay. I will keep going, but if anyone thinks of anything, feel free to share. Oh, someone in the chat said, what Sorry, I can't understand that second word. Do you think you could explain? Would you like to unmute and explain?
On when you are talking about how coding language improve, don't you when you mentioned speed, I saw something like
If the
C
question is what
Python.
is Python?
No,
Um, Python
what
is
is
a
meaning of C
programming
Python?
language, a coding language, where you as a user basically have to write out the code. But it was kind of created to be very simple and usable, user friendly. C Python is kind of a combination between the language C and Python, where and it kind of brings up this idea of like, if you can create a better combination, you can create a better single thing. So if the use of C Python can be more and more usable across the board, then the use of Python can also be. What's the interface for writing Python code? That is a great question. So there are a lot of coding interfaces out there. The one I like to use is called VS Code. I'll write that in the chat. But and then you need a terminal. But yeah, there's a lot of programs that can be downloaded onto your computer, where you can write code. And it's interesting because it's really only one. You really only need one program, right? Because you write your code and then you have a terminal at the bottom. I'll write that in the chat too. You have a terminal, which you can use to impact and run your code. So let's say you have a program that says you wanted to do 4 plus 4, right? You can write what it means to do 4 plus 4, give it your numbers, but then in order to actually run those numbers, you have to put in the terminal, run this code. And then, of course, you'll get this output. You'll get the output of 8, but you need to actually tell it to do that. It's not just going to do that all the time because you only want it to do it when you want it to, right? You don't want it to just keep doing it over and over and over. So yeah, I like to use VS Code, but there are many programs out there, many interfaces of which you can do Python. Now, an important thing to keep in mind is computers don't just automatically know Python, right? Because there's so many languages out there. So before using a program like VS Code, Python needs to be downloaded, right? Which can be done. You can get a download link at the Python website, right? And then once it's downloaded onto your computer, VS Code sees what you write and says, "Oh, I understand what this means." It's downloaded onto the device. Now, does that make sense? Does that make sense? Everybody? Okay, good. Now, so Python can be as complicated as you want it to be, and it can be as simple as you want it to be. But in essence, Python has 4 crucial parts that every line of code needs. The first being the function name. So in this case, it's print. So in Python, print is a built-in function used to output data on the standard output device. So if you go into VS Code and you write the following code, you write print, and then you write hello world, right? Just like we did in Scratch, exclamation. If you did that, the program needs to know what to do with the hello world. And this function tells it that it needs to print it, or in this case, type it out, right? So the print is telling us what needs to be done with the code. Now, the actual hello world is a string. It's called a string, meaning it's a sequence of characters, and a character can be anything from a letter, number, space, or symbol, enclosed in quotes. And Python knows to treat this single piece of data. It knows exactly how to treat it. So it knows that when you are saying print something, if you put this string in quotes, that is what it needs to print. So it's just basically this input that you're giving it, right? You're saying, hey, print hello world, or you're giving it the function print, and you're giving it the hello world. And in the black box, it puts them together and gives you an output where hello world is printed out. And then we have the parentheses, which are used to enclose the arguments of the function, so that the program knows when the line of code ends. And then of course you have the quotes, which just tells you exactly what you want to say. So that what I just put in the chat, the hello world, implies I want this program to say exactly capital HELLO, comma, space, capital WORLD, exclamation mark, right? It's exactly what's in those quotes. Yeah, and of course code can be more complicated, but this kind of represents the simplest version. Now I know I just went through a lot, so I would like to take some questions. Okay, no questions. Then my question to you, I have a question for you all, and that is, what do you think would happen if I forgot to put a quote? So what do you think of, I'm putting in the chat right now, what do you think would happen if I put that into my code? Or if I put that into VS Code and then wanted to run it? And I would like to hear a couple of you guys' ideas. Feel free to just speak out. What do you think? Do you think it'll work? And if not, what do you think will happen? So take a few minutes to think about that, and then we will share it. I'll just resend in the chat. Okay. Yeah, I'm seeing some ideas. Claire is saying I don't think it would work because there are no quotes. Alpha Lion is saying probably an error. Anthony is saying Python will print hello, comma world. These are all great ideas. I would like to hear. How about someone speaks out and explains their thinking? Anybody?
As you said, the four major parts
Okay.
of Python
Well,
is the function, the brackets, the quotes, and the text. So since the quote is missing, it is not going to take it as a legit
okay.
or
I'm seeing a lot of
complete Python program.
great ideas. And yeah, I just said that these are crucial components of a successful line of code, which means that in order to do anything, we need these four parts. We need the function, we need the two parentheses, and last but not least, we really, really need the quotes. So, because the quote represent where our writing begins and ends, without it, we just end up with an error. So if we say print hello world, see everything's the same except the quotes are missing here and here, right? We get this output, as you can see below. Can everybody see that? Where it says, it even tells us exactly where our problem is. It says, cell in 1, line 4. So in this line, here is the issue, and that is it is missing quotes. So it is called, that's why this concept called syntax is very important, because it is a syntax error. It doesn't know what this is, right? It doesn't know, it thinks it doesn't know where what we want it to print ends because there's no quote. It doesn't know where it begins. So the syntax of this, the actual grammar behind the statement, has an error because of the lack of quotes. Does that make sense to everybody? Does anyone have any questions about that? I'd like to take a few questions. Yeah. Yeah. Okay. If there's nothing, Now, Python can do so much more than just print, right? So for example, we were giving it this we were giving it this function where we asked it to print stuff, right? And in this case for us it said print hello world. However, Python, they all seem so simple, right? But Python is the combination of hundreds and hundreds and hundreds of different functions. And when they're all put together, they holistically work together and create an action. So one of the functions is len, which returns the length of an object. So for example, the len of Python, how many letters is Python? It would return a 6 because that is a number here. I'm looking here. So we have 6 characters, which means we would return a 6. Then we also have a function called type, which returns the type of an object. So if we give it a 42 and ask what type it is, it'll say it's an integer. If we give it a C for cat, it will say it's a letter, right? So it tells us what type. We have input, which is kind of like what we did in Scratch last lesson. It allows the user to input a string value. So for example, we can say name equals the input of what is your name. So it doesn't know, like in the question in the Python where I asked it to tell me the area of a rectangle, it knew the dimensions of the rectangle. But here it doesn't know the name, which means the name will be the response to what is your name, right? And then we have range, which generates a sequence of numbers, and is often used for looping a specific number of times. So for I in range 5, print I, and then it will print number 0 to 4. So this is similar to finding the multiples. Moving on, there are 5 more. We have int, float, or str. And these functions convert the arguments of an integer, floating point number, and string respectively. So, for example, int 10 converts the string 10 to the integer 10. Float 10.5 converts the string 10.5 to a floating point number. So the idea is just that it converts what isn't seen as an integer to a string. And it's very important because computers can read integers. So they read integers as they are. And computers don't always know what your string is. So when you say hello world, you have that string in quotes. It doesn't know what it is, but it doesn't care because it's a string. All it knows is what to do with it. So it's the same thing with these numbers. If we want a computer to say 10 as a string, irrelevant of what it says, we want to convert 10 instead of a computer seeing that and thinking, oh, there's 10 of something. We want it to see that and think, oh, this is just a 10. All I need to know. I don't need to know what it is. I only need to know that what needs to be done with it. And then there's sorting, where it will, sort numbers. There's open, which will open a file. Maximum and minimum, and then ABS, which is absolute value. So, as you can see, here's 10 crucial functions, and Python is simply made up of the combination of these functions. So Python isn't just asking something to print over and over, or asking something to sort numbers over and over. Python is where, in this example, we use the input function, we use the print function, we use the input function, and we use the len function, right? Python is just, when you write code, you're combining all of these functions to create an overarching idea that can do something for you. So in this case, we're using 4 different, just in this short thing, which will ask you your name, ask you your age, and then tell you, how many years or what year you'll turn 100 in, right? A very simple thing is already combining 3 of these different functions. And this is why I wanted to begin by introducing with Scratch, because Scratch is the same exact way. We have all these little blocks and we can combine and combine and combine. And I hope that you guys practiced and played around with this. You can keep combining these blocks to create something huge. But at the end of the day, they're all made up these little blocks that don't really do very minor things. And it's a combination of them that allow them to do bigger things. It's the same thing in Python. These functions do very minor things, but when we put them together and incorporate them together, they can do something bigger. Does that make sense? So yeah, it's a combination of many functions that can make a more complicated code. In this case, it's 4, and the code doesn't even do that much, right? Now, I would like to stop, pause, and take some questions. Any questions? Yeah. If you're raising your hand, would you like to just unmute or ask in the chat? Mm-hmm. Okay. Yeah, feel free to Lion, feel free to ask in the chat or unmute and ask the question. What is the difference between integer and float? Okay.
Good evening, or wherever is your time there. And please, I want to ask
So
for this.
it's just that it
There
has a
was
decimal point, a floating point number, and it will convert that from a value which a computer sees as a very specific value into a simple string, which a computer doesn't exactly know what it is, but also doesn't need to know. Anything else? Okay.
Okay.
Yeah, Destiny, do you have a question?
Okay. Yes, I have a question. There's a place you put hash. Greet the user. Can you hear me? Hello.
Mm-hmm. Okay. If there are no more questions, we'll move on.
There's a place you put hash. Greet the users. Then you
We'll
put
move on
print.
to
Then you
applying
print.
this new understanding that we have of Python to a black box theory. Oh yes, go ahead, Lion. You have a comment? Okay. So Python simply strives to create a simple input-output system where we give it an input and then Python does whatever we ask it to do to it and then does an output. So for example, if we give it an input of 7, 3, 19, and 100. Right, that's our input. And then in Python, we give it the function called sort, where it will put all the numbers in order. We get an output where all those numbers are put in their correct order. So yeah, so the important thing to understand here is the application of this black box theory, not only to Scratch, not only to Python, but to programming as a whole, and how it can keep on being applied. I'm seeing a few people have their hands raised. Are there questions? Or Destiny, do you have a question? Okay, now, putting it all together. So just like in Scratch, we have a system which is ask you what's your name and wait. Here in Python, we can do similar, except this is what it will look like, right? So this is a system where the system will think of a number between 1 and 100, and you can take attempts to guess it, right? So as you can see here, it shows guess is none because we've so far made 0 guesses. Attempts is 0 because we've so far made 0 attempts. And when we run the system, it will begin by saying, it will print this. So we use the print function to say, guess the number between 1 and 100. And then if it is greater than a number, then it will say higher. And if it's lower, it will say lower. And if we get it correct, it will print, congratulations, you guessed the number. And then it'll say in how many attempts, right? So using the program would look like something like this. I would say, look to the system in the terminal. I would say my first guess is 27. Okay, and then from this program, I would get a feedback. I would get feedback that says, or an output that would say lower. The number is lower. So then does anyone have any ideas of how to go lower? I would say 11, right? So my next guess is 11, and the system says higher. So I think, oh, it must be in between 27 and 11. So I think, let me go to 15. Okay. Yeah, so let's go to 15. And I think, okay, so if it's lower than 15, if it's lower than 15 but higher than 11, maybe it's 14. So I guess 14, and we get an output that says, congratulations, you guessed the number 14 correctly in 4 attempts. So as you can see, all the code here, which combines the print function, and uses a bunch of operations and combines a bunch of different functions, simply it uses numbers, where I give it a number and it says it has an option of 3 things to say back. It can say it's either higher, it can say it's lower, or it can say it's equal to. And this is this idea of a Boolean expression, right? That there's no in between. Well, it's either yes or no, right? It's either equal or it's higher, or it's not equal, but then it's higher or lower. So yeah, but this is Python, and the goal is to create, I can create kind of an understanding that, you can't really teach all of Python, but it's more understanding how the functions work, understanding how strings work, and then using kind of hoping that, and I hope that there's a way to kind of use VS Code to kind of play around with Python, right? And use these different functions and use the terminal to explore this incredible coding language. So applying these same ideas, the black box theory, I input any number, right? So for example, 27, and then the system will figure out what it is compared to the 14. So for example, 27 is higher than 14, and then the output will say it is higher. But then if I said 14, the output, it will do that whole system again, and the output will say it's correct. So this is what it looks after the fact, right? So the target number to guess at the top is 14. I first guessed 27, then 11, then 15, right? So I made 4 attempts. And then every time it thought, is the guess, which is this variable, which I put in, is it too low or is it too high? And then based on that, it gives us feedback of either higher or lower. However, and you see how it uses these conditionals. So it says, if the guess is too low, say higher. Else, if the guess is too high, say lower. And then it knows it can either be higher or lower, or there's only one other option. So it doesn't even need to say else anymore. It can say if the guess, so it only needs to say if the guess is neither too high or too low, it must be correct. And while this does seem like a bold assumption to make, it's the only option, because you can only be above a number or below a number or right in the middle, which is the correct number. So here in this case, it says if the guess is neither too high nor too low, it must be correct. So then give feedback, which is congratulations, you guessed the number. In this case, it's 4 tries, right? Because we have 4 tries here. Does that make sense to everybody? Okay, well, that's kind of, I kind of didn't want to overwhelm anybody. Python is a very vast and a lot can be done with it, and I'm hoping to spend multiple lessons teaching about it. But I hope this kind of created a strong fundamental understanding of how Python works. That Python is simply just like Scratch. It's a combination of functions that hundreds, many functions do this overarching thing you wanted to do. And it's the same thing with Scratch, where many blocks can do something in Scratch. Yeah, so that's all I have for today. But I'll stay on for 10 minutes to answer any questions. And of course, a recording of this, if you would like to rewatch it, will be on the YouTube channel and future lectures. And so yeah, next lesson I will go into kind of a more detailed idea of actually using Python. But I think it's very important to kind of create an understanding of how Python actually works and why it is very efficient. So, and I hope that lesson has done that. Future meetings can be found at 1 p.m. EST every Saturday and can be found at Zoom. I'll send the link in the chat. Yeah, and I hope, yeah, it was a bit of a briefer lesson, but I kind of want to slowly dive into these coding languages because they can be very complicated. And in the future, the hope is that I can actually kind of use the language in front of all of you and kind of show how the use case can actually be done. But I think this understanding will help. Recordings can be found at YouTube. A recording can be found at the link that I just sent in the chat. Yeah, so I'll stay on for a few minutes if there's any questions. But if not, that's all I have to say. So thank you. Thank you, everybody. Are there any questions or? Okay, well, if no questions, then at the next, if you come up with any questions, feel free to email me or write them down, and you can ask at the next class. But if that's it, then have a great evening, everybody, and see you next time.